Hi everyone. Today, I will explain a solution about implementation of composable banking based on Amazon Q Developer CLI. Today's traditional banks are facing three critical challenges. First, there's the issue of agility, the need to respond quickly to rapidly changing market conditions and customer demands. Second, new competitors like fintech companies are rapidly eroding market share with innovative services, threatening the position of established banks. Third, there's increasing pressure to develop and implement new business models alongside digital transformation. To overcome these challenges, banks need to transition from legacy systems to composable banking, which is the core of the solution we're presenting today. To address the agility, competitive, and digital transformation challenges discussed on the previous slide, we introduce composable banking. Composable banking breaks core business functions into packaged business capabilities, PBCs, each connected via API and event interfaces. Each PBC leverages internal data and metadata to deliver its specific functionality, and can be combined or separated at runtime for maximum flexibility. These standalone PBCs can be packaged as BaaS offerings, enabling rapid deployment and streamlined management. As a result, composable banking delivers high scalability and operational efficiency, serving as the cornerstone for modernizing legacy systems. Transitioning to composable banking requires shifting from legacy monolithic structures to microservice architecture, MSA-based composable banking frameworks. This involves a structural change from a single large database to multiple smaller databases, with Amazon MSK, managed streaming for Apache Kafka, playing a crucial role in this transformation. By leveraging MSK for data flow and event processing between services, we can effectively implement a loosely coupled microservice architecture. Notably, Amazon Q Developer CLI automates this complex transition process, significantly reducing developer burden and accelerating the transformation. This approach expedites legacy system modernization and greatly enhances business agility. Amazon Q Developer CLI spec-driven modernization provides a systematic process for modernizing legacy banking systems. The first phase, vibe assessment, involves entering prompts to thoroughly analyze existing application APIs, business logic, database structures, interfaces, and logs. Next, in the vibe coding phase, developers build template applications tailored to the modernization target and create target specs based on assessment results. Finally, in the modernize and test phase, the actual modernization work and testing are iteratively performed until successful completion based on the written specifications. This systematic approach is essential for reliably transitioning monolithic banking systems to composable banking architecture. This solution architecture illustrates the core structure for transforming a monolithic banking system into an agile and scalable composable banking architecture. We've redesigned the formerly unified system into independent microservices such as customer, account, product, and transfer, each managing its own business logic and data. In this architecture, we utilize REST APIs for service communication and implement the CQRS, Command Query Responsibility Segregation, pattern to separate read and write operations, enhancing performance and scalability. Notably, we've implemented a pub/sub messaging system based on Amazon MSK, managed streaming for Kafka, to enable loosely coupled and asynchronous communication between services, significantly enhancing the overall flexibility and resilience of the system. Amazon Q CLI modernizes a monolithic banking system by splitting it into modular composable units inside the migration demo directory. To verify the application is working properly, you can see the process of registering a new user, creating an account, and performing deposits and withdrawals through a web browser. Next, we will check that the customer API works correctly in the current monolithic banking system before transitioning it to a composable architecture. Modernization of the monolithic bank's customer module into a composable block begins with Amazon Q CLI. A global profile defines shared technical settings like software versions and tools. The customer profile includes an assessment of the module, and based on target files, modernization specs are pre-registered, including APIs, business logic, DB schemas, deployment scripts, and runtime configs. Since the specs define the targets, the modernization script only needs to specify the source, target, and completion criteria. Based on the entered prompts, QCLI refers to the registered specs and performs the modernization. The modernization is completed and testing is done. Following the instructions displayed by QCLI for starting the customer service, the service is launched and verified that the API works correctly. You can check the composable banking services deployed in advance on EKS and try invoking them through a newly developed user UI screen. E-demo of modernization using QCLI concludes. For complete implementation of composable banking, the ability to provide banking services in a SaaS model is essential, requiring transformation of existing architectures into SaaS frameworks. AWS SaaS Builder Toolkit is a proven tool that enables this transition quickly and efficiently, creating structures that can rapidly SaaSify existing banking services for delivery to diverse customers. This approach allows banking service providers to implement cost-effective and scalable architectures, while service users can adopt banking services quickly at affordable costs. AWS maximizes the core values of composable banking, flexibility, and scalability through the SaaS model, contributing to innovation and enhanced competitiveness in financial services. This slide illustrates the concrete architectural implementation of composable banking using AWS SaaS Builder Toolkit. By applying AWS existing banking systems can be rapidly transformed into a SaaS model, resulting in an optimized architecture based on industry best practices. This architecture clearly separates into a control plane, where service providers manage and control banking services, and an application plane, where customers access and utilize banking experiences. This structure achieves both scalability and cost efficiency while providing service providers with an effective management environment and customers with a seamless banking experience. This approach through AWS is essential for financial institutions to quickly build and launch modern banking services to market. What you are seeing now is the admin page for the BOS platform. This is where financial institutions register new corporate clients or tenants who wish to use their financial products. Today, we will walk through the process of registering a client named Any Company as an example. As you can see, the administrator enters the basic information for any company and clicks the Register button. This simple action kicks off the process of building an independent financial service environment specifically for any company. Once the client registration request is complete, the BOS platform first uses Amazon Cognito to automatically create a separate, dedicated authentication system for that client. This provides any company's end users with an independent and secure environment to log in. Simultaneously with setting up the authentication system, the core resources for the financial products that any company will use are deployed in the Amazon EKS, or Kubernetes, environment. The financial product services are deployed independently within an isolated namespace for each client, ensuring stability and security. After all deployments are automatically completed, you can see on the admin dashboard that any company has been successfully registered and its services are activated. The work for the financial institution is now done. From this point on, the process continues from the perspective of the client, Any Company. Now, an employee of Any Company, the tenant client, navigates to their own application screen to proceed with the financial product registration process. They log in securely using the Cognito authentication service that was automatically generated by the BOS platform. This is the dashboard that appears after logging in. Here, any company can select the services it needs from the various financial products offered by the financial institution and begin the registration process. With just a few simple inputs, any company can easily register and launch a new financial product to offer to its own customers. The scene now shifts to the end consumer. This customer attempts to log into any company's financial app. Upon logging in, the customer can see a new financial product that wasn't available before, the very deposit account that any company just registered. The customer can easily open an account through the app and immediately complete a deposit within the service, which is flexibly configured with a composable banking architecture. As demonstrated, a financial institution can effortlessly provide its financial services to other businesses through an AWS-based SaaS platform, without the need for complex infrastructure setup. Our solution offers 6 key benefits in transitioning legacy banking systems to composable banking. First, we automate legacy assessment and specification generation through Amazon QCLI, accelerating the initial phase of modernization. Second, we provide best practice templates optimized for composable banking, reducing development time while ensuring quality. Third, Our zero-touch testing and transition process operates without human intervention, minimizing error potential and ensuring reliable migration. Fourth, we enable rapid migration from monolithic to composable systems, significantly enhancing business agility. Fifth, by leveraging the AWS SaaS Builder Toolkit, we facilitate quick banking as a service platform deployment, reducing time to market. Finally, we automate tenant management, logging, billing, and core infrastructure setup, maximizing operational efficiency. Thank you.